This is matrix A. So the order goes like this, A, B, C, D. And there's a formula for the inverse. That's the formula you're going to get from me. So here's an example of how it worked. Okay, so I did 1 over AD. So you can see I did 3 times 4 for the AD. And the BC was the 5 times 2. Then I switched, so the D had to go here now, and I negated those. So it's just following a formula. Okay? Here's the rule. If you take any matrix times its inverse, any matrix times its inverse, it's going to make an identity. So that's what I wrote there. Any matrix times its inverse would be an identity. So that's what this means. Okay, so I just did the example from above. This was the original matrix. This is the inverse using the formula, and when I got the result, it was that. Okay, so here we go. Find the inverse and then prove that the original times the inverse is an identity. Okay, here we go. 1 over A times D. So you need to do top left times bottom right. So top left times bottom right. So negative 21 minus B times C. So top right, bottom left. 5 times negative 4 is negative 20. And then we're going to times it by, so the A and the D diagonals have to switch positions. So switch those two, because you see AD, now it's DA. So switching the positions there means negative 3 there and 7 there. And then B gets negated and C gets negated. So the 5 is now negative 5 and the negative 4 is now positive 4. What's this value in the front here when you finish this fraction? It's just negative 1. And then if I times the negative 1 by that, it would be positive 3, positive 5, negative 4, and negative 7. So there's my inverse. So here's what we're going to try to do. We're going to show that the original A times the inverse should end up being a 1, 0, 0, 1 matrix. Okay, so my original was 7, 5, negative 4, negative 3. So here's the original, here's the inverse. Okay, do you remember how to do multiplication of matrices? The row times the column. Okay, so here's our combinations. I'm going to have to put row 1 with column 1. So I'll just give you one visual here. Row 1 times column 1 like that. So I'm going to go like this. 7 times 3 is 21 minus 20. Okay, row 1 with column 2. So row 1 with the second column will match to be 35 minus 35. 35 minus 35. Okay, now I'm going to tie together row 2 with column 1. So that would be negative 12 plus 12. And then the last combo is going to have row 2 matching with column 2. Row 2 with column 2. So negative 20 plus 21. There we go. When I simplify it, that's my answer. So I showed you that any matrix times its inverse would be an identity. Okay, yay or nay to me doing the exact same thing? Nay? Nay? Okay, moving on. That other example was the exact same. Okay, we're going to solve this system using that method. Okay, so I'm going to make two different matrices here. So this is kind of going to be my front one with my variables. So this was my 5x, 2y. This is my 3x, 3y. And then these were the equals 8 and equals 3. Okay, so we need to do the inverse of this. Okay, so using the formula, 1 over. Okay, so you're going to have to do A times D, so top left, bottom right. So that's going to be 15 minus, so following this formula, B times C. B times C is 2 times 3, so 6. Okay, now on this position of the matrix, we have to switch A and D and negate BC's. So 3 and 5, 5 and 3 become 3 and 5 switched. And then negate, negate. Switch those, negate those. Okay, so my coefficient in the front is going to be 1/9. Okay, so I'm going to times everything by 1/9. So 3/9, negative 2/9, negative 3/9, and 5/9. And I'm just going to leave it. I know some of them can reduce, but I'm just going to leave it so that everything's going to be with a 9. Okay, that is my inverse. Okay, so here's what I'm going to do. I'm going to take my original. So I had this for the variables equals this for the answers. Okay, I'm going to do. I'm going to leave a little space there because I have to do something. Okay, so this was my original. And here's what I'm going to do. I'm going to times both sides by the inverse. Can we do that in math? If we do something to one side, we can do that to the other, right? So I'm going to times by the inverse. And I'm going to times by the inverse. Does anybody know why I wrote this in front instead of behind it? If I wrote this over here, I wouldn't be able to do it. Why? Right now I have a 2 by 2 timesing a 2 by 1. Is that going to work? Yes. Okay. If you had it the other way, you wouldn't have been able to do it. Okay, so that's why I had to write it in the front. Okay, now we're not going to do this the long way. We know. What does an inverse times its original make? Identity. I'm not going to do the long way. We just proved that that's going to work. Okay? Now we got to do this side. Okay, row 1 and column 1. You ready? Here we go. 24 over 9. 24 over 9. Minus 6 over 9. Now I'm going to do row 2 with column 1. So this is going to be negative 24 over 9. And this is going to be 15 over 9. Okay, should we do this? What's 24 minus 6? 18 over 9? 2. Negative 24 plus 15. What are we getting with that? Negative 9. Negative 9. Negative 9 over 9 is negative 1. So what's my conclusion here? 1x is 2. And this is the y equals negative 1. There we go. We solved it in another way. Okay, the next example is a repetition again. Another one or done? This question is the same as me doing like that. Do you want one more of them or no? You want to try?